Cost approach, application, and limitation. The value of an improvement can always be related to its cost regardless of the market. The cost approach is particularly important when there is lack of market activity, which limits the use of the sales comparison approach, and when properties to be valued are not amenable to the income approach. Cost and market value are usually more closely related when properties are new construction. This approach is very useful when the land/site value is well documented and the improvement represents the highest and best use. The cost approach is also used to develop an opinion of market value for proposed construction, special purpose properties, or other types of properties not frequently exchanged in the marketplace. The cost approach is very useful when improvement additions or renovations are being considered. The appraiser can estimate whether the addition or renovation, including all costs, direct, indirect, entrepreneurial profit incentive, can be recovered through the anticipated sale price or through an increase in the property's improved income stream. The cost approach is limited only by the skill of the appraiser and the analysis of current market data. While estimating the cost by any of the four methods is relatively straightforward, estimating the depreciation is frequently the subject of debate. The estimation of depreciation is considered in detail in Chapter 10, The Cost Approach to Value Depreciation. If there are enough comparable sales to the subject improvement, then depreciation from the market can be extracted. That usually can be performed only on single-family properties, not complex commercial and utility properties for which many adjustments, contributions need to be made. In using the observed condition breakdown method of depreciation, the appraiser must understand depreciation and have adequate skill in order to accurately estimate the depreciation. When improvements are considerably older or do not represent the highest and best use of the land as though vacant, the depreciation may be more difficult to estimate. Also, relevant comparable sales may be lacking, or the data from the comparable sales may be too diverse to estimate depreciation components from the market. Another weakness of the cost approach from an investor's perspective is the assumption that newly constructed properties are available on the appraisal date. Investors looking for an immediate purchase may consider the time required to develop and construct a new property to be unacceptable. In that situation, the cost approach has no relevance to the investor. The cost approach has limited applicability in circumstances in which the improvements no longer represent the highest and best use of the site as vacant. It is a violation of the consistent use principle to value the land/site based on one use and the improvement based on a different use. A violation of the consistent use principle generally results in an artificially high value indication by the cost approach. Improvement data. An inspection and a suitable description of the site improvements, including the building, should be the first step in the cost approach. The assessor, armed with a description and a value estimate of the site, usually has property record forms that assist in making a thorough inspection of the building. It is necessary to observe the quality, condition, and adequacy of each component and of the whole. In general, the following elements should be rated for quality, workmanship, and special physical characteristics. Overall quality. Use type, residential, commercial, industrial, and so on. Construction grade, minimal, fair, average, good, very good, and excellent. Structure, foundation and framing. Exterior, frame, masonry, log. Roof type, pitch, cover, gutters, and eaves. Wiring and fixtures, type and grade. Windows, type, screens, storm windows. Plumbing, type and grade. Heating and air conditioning, type and capacity. Special features, equipment. Room and finish detail, floors, walks, and trim. Bathroom details, number, type, and grade. Construction record, year built, effective age, remaining economic life. Miscellaneous improvements. In addition to recording and rating these features, the assessor should make a sketch of the building's dimensions and calculate square foot and/or cubic foot areas. Characteristics of cost. Cost has many characteristics that affect the dollar amount of the cost. Some improvement characteristics that affect the cost are as follows: quality of workmanship, quality of materials, design type, construction type, floor area, building shape, story height. For example, a dollar impact on the cost, For example, the quality of the construction materials and the skill of the labor force have a dollar impact on the cost. The complexity of the design, such as pitch of the roof, ceiling height, and exterior wall thickness, can affect the cost. The construction type, such as framing the improvement with wood, metal, logs, or block or brick masonry, is yet another characteristic of cost. Other characteristics of cost are floor area, building shape, and story height. The floor area or size of the improvement, as well as the building shape, can affect the cost. Often the larger the floor area up to a certain point, the lower the dollar per square foot of floor area, and vice versa. The smaller floor area, the higher the cost per square foot. See Figure 9.2 later in this chapter for descriptive examples of floor area and building shape in the discussion of cost manuals. Cost estimation. Cost estimation is the process by which the cost new of the improvements is obtained. The process begins after all the pertinent physical data on the improvements have been collected. Elements of cost. Cost consists of all the direct labor and materials and indirect expenditures required to complete the construction of an improvement. A builder or developer includes all expenses incurred in the development of an improvement, as well as overhead and a sufficient amount of profit to cover the risk associated with constructing the improvement. Thus, if cost is to represent value, all appropriate cost must be included in the estimate. The goal of the assessor is not the cost value, but the market value. Cost is merely the avenue to market value in this approach. Cost can be divided into 4 parts. Direct costs. They are expenditures for the labor and material used in the construction of the improvements, as well as the contractor's profit required to construct the improvement on the effective appraisal date, often referred to as hard costs, or costs that can usually be seen occurring at the construction site. Indirect costs. They are expenditures or allowances for items other than labor and materials that are necessary for construction of the improvement, but not typically part of the construction contract, often referred to as soft costs, or costs that can't usually be seen occurring at the site, such as office costs.
Off-site costs.
Oh, sure is off-site cost. How about that? Entrepreneurial profit. a market-derived figure that represents the amount of the entrepreneur receives for his or her contribution to a project and risk. The difference between the total cost of a property, cost of development, and its market value, property value after completion, which represents the entrepreneur's compensation for the risk and enterprise associated with development. Entrepreneurial incentive, a market-derived figure that represents the amount an entrepreneur expects or wants to receive as compensation for providing coordination and expertise and assuming the risks associated with the development of a project. Incentive is the forecasted reward entrepreneurs expect and is projected before the completion of the construction. Examples of direct and indirect costs are presented in Table 9.1. Table 9.1. Examples of direct and indirect costs. Direct costs, which are hard, labor used in construction, materials, security during construction, equipment rental, utility costs, building permits, material storage buildings, contractors' trailer, building, and other temporary needs such as fencing, and contractors' profit and overhead. Indirect costs, or soft costs, architecture and engineering fees, accounting and appraisal fees, title and legal expenses, insurance, real estate taxes during construction, construction loan fees, marketing, advertising, and sales expense, and cost of carrying the investment after completion but before stabilization is realized. Entrepreneurial profit for a new building that is the highest and best use of the site is the difference between the market value of the completed property and the total cost of development. The market-derived number represents the amount of risk and developer skill that is linked to the development of an improvement or project and is the anticipated profit over direct or indirect cost. Example: market value less the total cost of development is equal to entrepreneurial profit or loss. Entrepreneurial profit is realized only when the property is first sold, even if the sale takes place years after the property was built. Over time, it becomes obscured by the appreciation in property value. Interviews with developers regarding anticipated profit may help in estimating entrepreneurial motivation. When using manuals or actual cost submissions, the assessor must learn to what extent all direct and indirect costs are reported. Concepts of estimating cost. There are 4 concepts of estimating cost: reproduction cost, replacement cost, historical cost, and trended historical cost, sometimes referred to as trended reproduction cost. Reproduction cost is the cost of producing an exact replica of a building or improvement using the same or very similar materials, design, and workmanship. This cost involves rebuilding the subject structure with any inherent faulty designs, superadequacies, and inefficiencies. It is an unrealistic method for older, obsolete structures because virtually no one would waste money erecting such inefficient and expensive improvements. Replacement cost. Replacement cost is the current cost of producing a building or improvement with the same utility but with modern materials, design, and workmanship. This cost is less than the amount indicated by the reproduction cost method. It implies that the cost is based on a modern improvement that affords utility equivalent to that provided by the appraised improvement. Historical cost is the cost of a property when it was originally constructed. Sometimes the terms historical cost and original cost are used interchangeably. However, original cost is an accounting term defined as the acquisition cost of a property or asset to its present owner, that is, the net invoice price of an asset.
Is that true?
Acquisition cost, yeah.
Okay.
Trended historical cost is the historical cost factored by reference to some current index for property components. Theoretically, it does not matter which type of cost is used for estimating market value as long as depreciation is measured accurately and fitted to the type of cost. However, there is no need to perform all four estimates of cost, only the one that is best applicable to the type of property being appraised. The final estimate of value after depreciation has been accounted for and the site value has been added back should be the same or very nearly the same for each type of cost if the data are available and correctly applied. Typical cost should be used for estimating any of the four types of cost. Actual costs for similar properties sometimes vary unpredictably, just as sales prices vary among similar properties. The degree to which a cost estimate approximates reproduction cost rather than replacement cost is affected by how costs are estimated. Generalized cost estimation techniques tend to produce replacement cost. Detailed methods that recognize unique features of the subject property tend to produce reproduction cost. Reproduction cost includes the added expense of obsolete or costly design, building techniques, and material. Special purpose properties sometimes require more detailed cost estimates. Frequently, historical cost trended upward by a current index is applied to special purpose properties for which no cost new estimates can be obtained. If the structures are old, building materials and standards may be obsolete, so that estimating reproduction cost may require much time and great expense. In private as well as public construction, contractors' bids may vary substantially. Cost estimation is not an exact science. Selection of a bid requires judgment of which contractor will complete the job satisfactorily at the lowest cost and with no undue risk. On occasion, costs are higher than usual, for example, when a premium is paid to shorten the construction period or when the bid process is prejudiced. Assessors should disregard or adjust for an atypical cost when developing cost schedules. Costs should reflect the local market and be current as of the appraisal date. If nationally published manuals are used, the assessor should confirm the data on buildings of known cost and make local adjustments as necessary. Profit margins, in particular, can vary with local economic conditions. Most manuals contain indexes for adjusting reporting costs for time. Manuals that are developed in-house should be kept current through annual indexing of costs and periodic revisions. The usefulness of cost as a representation of value must be kept in its proper context. The assessor-appraiser should remember that the objective is market value, not cost. Cost estimating is not appraising. It is only one step in the appraisal process. Appraising is an orderly and disciplined method of estimating the most probable selling price of a property. Cost estimation, although it states the development cost of a new property, does not indicate the ultimate value of the property. Other factors, general economy, market, supply and demand, and location, influence value and must be accounted for as previously discussed. An opinion of market value requires a market for the property. If there are no buyers for the subject property in its current use, an alternative must be considered. Using the cost approach to value a special use or special purpose property where no market exists usually overstates the market value of the property. Methods of estimating cost. The methods of estimating current cost can be placed in four categories: the quantity survey method, the unit in place method, the square foot, cubic foot, or comparative unit method, and the trended historical cost method, sometimes referred to as factored historical cost. Quantity survey method. The quantity survey method is a complete cost itemization of all direct and indirect costs incurred in the construction of a building. It is the method generally used by engineers, architects, contractors, cost estimators, and builders, and is the most comprehensive and accurate method of cost estimation. A quantity survey reflects the quantity and quality of all materials and all types of labor required. Unit costs are applied to these figures to arrive at a total cost estimate for materials and labor. Then the cost estimator adds a margin for contingencies, overhead, and profit. Under the quantity survey method, bids for major construction work are obtained by the general contractor from subcontractors and summarized to derive the composite cost estimate. The quantity survey method, if expertly applied, produces fairly accurate results. The application, however, is often too time-consuming and costly to be recommended for use in most appraisal assessor assignments. Highly trained cost estimators who are conversant with the operational details and technology of the building industry are required to apply this method with assurance and relative accuracy. Table 9.2 shows an example of the method for estimating exterior wall cost. The quantity of each part or item of raw material for each component of the structure is inventoried and a price determined and listed. Costs for other building components are estimated in the same way and added to overhead, profit, and other indirect costs to arrive at total reproduction cost new. Table 9.2. Quantity survey method for estimating costs of exterior walls.
You can skip down to the
Skipping that?
top.
Assessors occasionally use the quantity survey method to estimate reproduction cost of large special purpose properties for which other methods may not be sufficient or accurate. The method also can be used to estimate the reproduction cost of benchmark structures from which local cost schedules and indexes are developed. Assessors may also encounter the quantity survey method in valuation appeals, although the quantity survey method is seldom used by the assessor because it requires great detail. It is the basis for developing the unit in place method of cost estimation. Unit in place method. The unit in place or segregated cost method is a modification to the quantity survey method and is frequently used by architects, appraisers, and assessors who require a considerable degree of detail and accuracy. In this method, only costs of structural units installed in place as charged by the various subcontractors or incurred by the general contractor are itemized and summarized. This method combines direct costs, labor, materials, and overhead into a single unit in place figure, which, when multiplied by the area of the portion of the building being priced, results in a total cost estimate for that portion. Every building component is similarly calculated and added together to provide the estimated direct cost of the entire improvement. The unit in place cost estimation is not limited to cubic feet, linear feet, or square feet. The measure on which the cost is based may be the measure employed in a particular trade, such as the cost per ton of air conditioning. The unit in place method also may be applied to the cost of complete installed components, the cost of complete installed components, such as the cost of a roof truss that is built off-site, delivered, and then installed. When completed, the unit in place method provides a substitute for the quantity survey and produces an accurate cost estimate with much less effort. Unit in place costs include all direct labor and material costs. For example, roof support costs include all materials needed for trusses, rafters, sheathing, or decking, as well as all related labor costs. These costs may vary by roof pitch and other factors. Similarly, roof covering costs include felt paper, shingles, drip edges, flashing, and any other material, plus all related labor. In both cases, costs are expressed as cost per square foot of roof surface. Items such as the foundation, floor, roof, roofing, electrical, and the like are considered horizontal costs and are expressed as cost per square foot. Components such as exterior walls and interior partitions are considered vertical costs and are expressed at a cost per lineal foot. Items that are constant cost components such as unit heaters, elevators, water heaters, and so on are expressed as lump sum costs. To estimate total cost for a component, the unit cost of that component is multiplied by the number of units in a building. For example, if the unit cost of acoustical tile is $3.12 per foot installed,
Per square foot.
isn't that what I said?
You said per foot.
Oh, per square foot installed, and 8,660 square feet is required, then the replacement cost new of that component is $27,019. The appraiser must know exactly what is included in any unit price quoted. Indirect costs are typically computed separately. To obtain a total cost estimate, the appraiser must be careful not to double count. Costs for exterior and interior walls are expressed as cost per linear foot. The cost of interior walls, for example, might include costs for the following: 2-inch by 4-inch by 8-foot studs, single bottom plate, double top plate, half-inch drywall taped and sanded on both sides, metal corner head on outside corners, 1 prime coat of paint, 1 finish coat of paint. If cost is calculated to be $45 per linear foot and a structure has 120 linear feet, the total cost for this component is 120 times $45, which equals $5,400. Table 9.3 presents a complete example of the unit in place method applied to a hypothetical structure. This method is detailed and highly accurate, although not as precise as the quantity survey method. Builders and contractors often use the unit in place method for developing cost estimates. Many cost manuals contain unit in place sections that assessors can use to adjust for features not included in the base specifications for a given building class. Assessors can also use the method to estimate costs for unusual or special purpose structures. Comparative unit method. The comparative unit method is the easier, fastest, and most widely used method of cost estimation. Costs are summed and divided by an appropriate unit, square feet of ground area or floor area, or cubic feet, to derive a cost per unit. Unit cost figures are typically expressed in terms of gross building dimensions converted into square or cubic feet. Total cost is estimated by comparing the subject improvement with similar, recently constructed buildings for which contract prices can be obtained. The trend in cost between the effective date and the appraisal and the contract or construction price should be factored into the comparison. For example, the replacement cost for 2-story residences of standard quality with 1,500 square feet of living area is $195,000. This cost divided by 1,500 square feet equals $130 per square foot, which is the unit of comparison for the structure of this type. Comparative unit costs can be obtained from recognized cost manuals or developed locally from an analysis of actual costs of benchmark structures. These costs are arranged in schedules based on type and quality of construction, size, and perhaps shape. Unit costs for the benchmarks improvements found in cost estimating manuals usually start with a base building of a specified size. Adjustments and refinements are then made to the base cost for any differences between the subject improvement and the benchmark improvement. If the subject improvement is larger than the benchmark improvement, the unit cost is typically lower. The reverse is typically true if the subject improvement is smaller, that is, the unit cost is typically higher. Few improvements are identical in size, design, and other characteristics of cost. Therefore, the benchmark improvement typically is different from the subject improvement. The simplicity of the comparative unit method can be misleading. To develop dependable unit cost figures, an appraiser must exercise judgment and carefully compare the subject improvement with similar or benchmark structures for which actual costs are known. Errors occur if the appraiser selects a unit cost that is not comparable to the subject improvement being appraised. When the comparative unit method is correctly applied, however, the method produces a reasonably accurate estimate of cost. As with all methods of cost estimation, accuracy depends on the quality of the data used in the analysis. All costs must be included in the comparative unit method. Cost manuals rarely include all indirect costs or an allowance for entrepreneurial profit, so adjustments must be made to obtain an indication of the total cost. Emphasis should be placed on understanding the cost data and its source along with what the cost does and does not include. The chosen units of comparison should be based on local industry standards. Usually, ground or total square footage is used for residential and commercial structures. A volume unit such as cubic feet may be preferred for a warehouse and industrial structure. Although not as precise as the unit in place and quantity survey methods, the comparative unit method ensures that costs are typical and products reliable replacement cost new estimates. Costs produced by this method also can be converted to formulas for use in mass appraisal. Table 9.4 presents comparative unit costs for 4 levels of quality and 1- and 2-story residences with different floor areas. Percentage or lump sum adjustments for features not included in comparative unit costs can be made with the unit in place method. For example, using Table 9.4 for a standard quality 2-story residence with 1,150 square feet of living area, replacement cost is estimated as follows: $79.26 multiplied by 1,150 square feet, resulting in a total of $91,149. Do you want me to read this table?
No.
Do you want me to go back and catch Table 9.3?
No. I have it.
Oh, okay.
It's a big, long table.
It's that big giant table, yes.
No, I wouldn't do that to you. And I think it'd be too hard anyway to look at that or think about it and stay somewhere when you're just listening to it.
Okay. Trended historical cost method. The trended historical cost method, sometimes referred to as factored historical cost or trended reproduction cost, obtains an estimate of the reproduction cost of a structure by trending its historical cost with a factor from an appropriate construction cost index. The method is used to estimate current costs of structures for which comparable cost data are not readily available. Special purpose properties and utility properties for which historical cost figures are available to the appraiser are examples of the type of property for which this method is appropriate in the appraisal process. The method also is useful for estimating the cost of large industrial properties that would take too long to describe accurately enough for the unit in place or quantity survey methods. Trended historical cost can also be used to validate cost estimates produced by other cost methods. It is especially useful for updating the cost estimate of recently constructed properties. For example, a 200-bed general hospital was built 9 years ago for $15,706,000. An appropriate cost index states that hospital construction costs have since increased 68.3%. The trended historical cost, rounded, would be $15,706,000 times 1.683 to equal $26,433,198. The method relies on the knowledge of the date of historical cost of construction. The appraiser must ensure that the historical costs provided do not include values attributable to land, personal property, or site improvements. Further, the reported historical cost should be adjusted to exclude extraneous or atypical cost and to include unrecorded cost. Such determinations should be made by an assessor skilled in auditing construction cost records.